And this is commentator Dan Hewitt here in Mission Control. While we continue to look on and see some of the exciting robotics activity taking place on board the station, we also have some really exciting stuff that's going to be taking place tomorrow. Now, joining me on the phone from MIT up in Massachusetts is the principal investigator of the experiment known as Spheres, Dr. Alvar Sáenz Otero. Dr. Alvar, first off, thank you so much for being here today.
Dan, thank you very much. Good morning.
Yes, good morning. And so, Spheres Zero Robotics. First off, Spheres, it's an acronym. Tell me what it stands for, real quick.
Sure, although I don't think many people remember. It's the Synchronized Position, Hold, Engage, Reorient Experimental Satellites. It's a really long acronym, and the keywords are synchronize and position and reorient. Basically, it means when multiple satellites are synchronized to work to do something together.
Okay, and these spheres have been used on board the station in quite a number of runs, over the past couple of months and years, actually. And I understand that you were heavily involved. Why don't you tell us a little bit more about the history of this project?
Sure. I guess there's two parts. Let me just summarize the space station part. We actually began operations aboard space station back in 2006. That's when the first of the spheres arrived, and the other two followed shortly thereafter. Because we're a distributed experiment, so one of the good things is we could start doing research even before all of the three satellites were there. We could already do tests and checkouts and collect some of the data we needed. And since then, we've completed 35 test sessions. So 35 sets of tests to reach some sort of science objective. And tomorrow is the 36th one. It's the 36th time that we complete a test plan, and tomorrow's will be the Zero Robotics final. But another really interesting part about Spheres is that it was the first one on what is now a series of, I believe, 9 classes at MIT, where undergraduate students design what will ultimately be space hardware. So instead of giving students an individual thesis project at the end, we gave the whole group the joint responsibility for their thesis as a whole to design spheres, and that was a great experience. And now, fortunately, there's dozens of schools around the world copying that format. So I guess we did a good job.
And I mean, that sounds really exciting. Anytime we can get students involved, and especially giving students a chance to have something actually flying up on station that they're controlling or involved in, it's got to be really exciting for them. Now, tomorrow's activity, I understand, is with high school students.
That's right. A couple years ago, back when we were doing training with astronaut Greg Chamitov, who himself is an MIT alum, and more importantly, who for his PhD did control systems. So he knew all about how to control satellites and basically the purpose of spheres. And he asked us a very simple question. The way we design spheres is very safe. There's nothing we can program the sphere to do that presents any safety concerns to, obviously, the crew, most importantly, to the space station, or even to the satellites themselves. So no matter what people program on spheres, the satellites are safe, and from every perspective. So since there's no restrictions there, he asked us, well, why are you restricting that to college students? Why is it only college and not younger students? And usually when you ask an engineer a question and they cannot answer why not, they have to do it. So we designed this competition. We looked around and we learned a lot. As the name suggests, we got inspired by First Robotics. We actually contacted them and then got permission to use the name Zero Robotics. They said it was not a problem. So we made Zero Robotics, and what Zero stands for is zero G. Although we all know that space station is actually microgravity, not true zero gravity, but close enough for any engineering approximation for our objectives here. And the other zero is also zero cost. We wanted to make this a possibility for high school students at no cost to them except for their effort and time to be able to work with space station. So modeling, using First Robotics as a model, we created a competition for high school students and later on for middle school students. So in 2013, we're going to do middle school students too, where we design a game just like First Robotics does, but instead of the students building robots, they're going to program robots. So I like to call ourselves the software complement to FIRST Robotics. FIRST Robotics is mostly about hardware. We are pretty much all about software. But with that way, because it's all software, we designed a website that online is everything is done online. The students online do the programming, they view simulations, they interpret the results, they see how they're doing in the competition. So basically, Zero Robotics is a software competition. It's a way for students to learn about programming and how to control satellites. And the finalists, the very best ones, and that's what we're going to see tomorrow, they get to test their code on our hardware aboard space station. So they already went through 3 rounds of simulations. They already did the whole semester. They began back in September. And they did all the simulations, and tomorrow they're ready to go. Their code is now in space station, and it's just waiting for the astronaut to turn satellites on tomorrow. And we're going to see who wins in the real world instead of in simulation.
That's right, and it'll be really exciting, too. We're certainly looking forward, and we'll be following along. And just real quick, I mean, this is such an amazing tool. Can you tell me the kind of response you generally get? Like, how excited are these students that they're manipulating something that's flying, 250 miles above them?
Well, let me tell you that tomorrow in the room we're going to have 21. Actually, no, I believe 20. Yeah, I think it's 21 or 23 teams. I have to double check the final attendance list, but it's at least 21 teams of high school students who we gave no money to, and they found their own funding to come to MIT to see it. So it wasn't just, it's not just the excitement of working in the station. I love to see that action, right? They actually took the action of going and fundraising on their own to find money to come to MIT to watch these finals. To me, that's an amazing example of how interested they are, because they're in high school. They don't really do fundraising very much. So it's extremely exciting. In this year, our estimate, because we don't force people to give us full rosters of their teams. That's not our objective. Our objective is to make sure that they have at least 5 students in each team. But we estimate we had about 1,700 students participating this year, and it's only our second year of doing this at a national level.
Wow!
So in 2 years we're reaching over 1,500 students for sure, and I'm hoping close to 2,000, but I don't want to quite promise that.
Well, it certainly sounds like you guys are off to a great start, and we hope it can only grow, because it really is. It's an amazing tool to get students involved in STEM, science, technology, engineering, and math. And I mean, we're certainly going to be looking forward to it, and we'll be making sure that we watch the competition tomorrow and see who wins. So, Dr. Alvar, thanks so much for coming on with me real quick and giving us a look inside Zero Robotics. Good luck to all the teams from Mission Control, and we'll be watching.
Thank you very much, Dan. And yes, we'll be on NASA TV, and we'll also have a webcast direct off our website, which is zerorobotics.mit.edu, for anybody who wants to watch it, either on NASA TV or our website. Tomorrow, we start at 8:30 in the morning and go until 1 o'clock. There's a lot of competition to run.
Okay, we'll be following along.
Thank you.
Thank you.
Bye-bye.